Okay, everybody, we're going to be working on Unit 9 homework here. And basically, our goal is to normalize um, a database table, create a database, and have a entity relationship diagram. There is a Word document that's attached, and there's kind of the raw form of the table here. Um, and maybe a good place to start actually is to kind of let's just look at the raw form of the data right now and see what issues we have with this. Because I think there's definitely some issues here. Um, so let's look at what this table holds. It says there's a project code, a project title, a project manager, a budget, an employee number, an employee name, a department number, a department name, and an hourly rate. And I'm hoping that you can just like right off the bat, first just notice that some rows don't have complete information. So I don't know what that means. Does that mean that for this pension system with M. Phillips, that Smith, Jones, and Lewis are involved? And the same thing here, is that what that means? We're not sure, right? So these are issues that we have to handle. Another thing that I notice is the names are combined. They have first initial, last name. It's probably not a good way to do it. We also have employee names the same way, and employee numbers. It would probably make more sense to have employees in a separate table. We also have department numbers and department names. That's also kind of redundant. That could be another table. And then I'm not sure what the hourly rate relates to. But you see, this is like somebody captured the information. They maybe just typed it into a spreadsheet. It makes sense to them. It's informative for them. But putting it into a database is a different thing, right? Now, that's really what the point of this exercise is to be clear about, how information is grouped, why it's grouped together, and to make it efficient. Okay. So the other thing I noticed too, and this is kind of like one of those weird things, right? You may or may not notice, like they have a project title. You notice how all the project titles have the word system in them. So it's pension system, salary system, HR system, whatever. Couldn't we just call it pensions, salaries, HR, for example? Yeah, we totally could. Right. So these are the types of things you look for when you're doing normalization. And it's good to kind of deal with it in its raw format. Please notice we do have a raw CSV file here. So you should grab that and download it. Right. And let's look at it. Okay, so I'm going to open it up. And then as you open it up, it's going to come up in Excel for me. You notice that we basically have the same information we were just looking at, but now it's sitting inside of Excel. I'm just making sure that all the columns are expanded. I notice a whole bunch of issues. Okay, so, and this is another concern. All right, so here's the kind of goofy stuff we're trying to train you on. And I'm going to say, especially if you're in the data analytics program, I want you guys to be even more particular about this. Web people might not care quite so much. Here's some things that catch my eye. All right. I look at the project column, right? And then I notice, oh, this is PCOIO, or is this 010? Okay, so if I look back at the course shell here and look at it in this format, okay, well, these look all like numbers to me. But in the raw data set, these are not numbers. In fact, these are all letters. And so the data is inconsistent. So I would argue that if I was going to normalize this, this might need to be converted to the numerical format as we saw on the website. Because right now, those are letters, not numbers. How do I know? Look down here and look at how the 0, like on row 5 and 6, is narrow, and how the O is wider, and how I can test it too. So I can type a capital letter O, and I can type a 0, and I can see the difference. and I can type a one or type the letter L and I see the difference. So I think one of your tasks, and I'm not telling you, I think I'm telling you one of your tasks is you need to clean up that data. And this is the thing that we teach our data analytics people. So that's the more correct data format, I think, right? So you would want to clean up your data. And since you're looking at that kind of detail, which you should, then you'll want to really be careful. It's like these all look okay. Oh wait, here's a weird one, right? There's one that has, right? So that should be L006, and that should be L00S. And I think those are the only ones that are weird there. I also noticed this anomaly here, right? I also see, okay, is that misspelled or is that just truncated? Oh yeah, that's just misspelled. That's a V, it's not a Y. Right. So you see like, some of the issues here. I also noticed in the hourly rate, same thing happened. All right, well, some of the numbers have decimal places, some don't. This one once again has that issue. Maybe they did like OCR and captured the data and the data wasn't clean and it came in as IS instead of 15. I can look back again here and go, aha, no, oh, it's supposed to be 1850 and that says IS 50. So I'm going to type in 18.5, right? Um, and then I would do that. That one's supposed to be 18. So I would just type it in, right? And fix it. 1850. So in that case, I can copy, and then I'll assume this one's 18 again. But data integrity is important. Misspellings are problematic, right? Mixing numbers and letters, problematic. These are all not good things. And so one of the jobs of a database person or a data person, right, or an IT person is to fix that kind of silly stuff, right? Especially with raw data, you don't know where it's coming from, how it's captured, who typed it in, or whatever. But looking at data integrity is important, right? So when we say data integrity, this is what we mean. It's different if I say IS 50 rather than 1850. Well, then I also notice like these are hourly rates. Maybe I can, like in a spreadsheet, do this, right? You know, that looks better, for example. And I could make it a monetary value, but whatever. All right. So I think for the most part, the data's cleaned up now. And then we would kind of process it from there. So then we go to the assignment here and we click on this document. We'll pull up the document to guide our work. So I'm just going to open this up and I'll turn on the editing for it. And I'm going to zoom in just a little bit. All right, so here they give you the raw data once again. All right, and there's little warnings there. All right, so we're going to do first normal form. So identify repeating attributes. And this is one of these assignments, I'm not going to give you all the answers for this because I do want you to think about it. And it says, identify the repeating attributes, remove these repeating attributes to a new table with a copy of the key from the UNF table, meaning the unnormalized table. So UNF, by the way, stands for unnormal form or something like that, right? It's unnormalized. It's not ordered, right? As you create new tables, you would assign a key and then underline it so that we know where you could do like what we saw in the example. You could mark it as a PK or FK for a foreign key. So something that you might do, and the reason we do this data in an Excel file is, the first thing I did, and here's the mistake I made. I should have left the original data alone and made a copy of it, right? And so, and the way that you do that in Excel, you can do this in Google Docs too, if you wish, is you can create a copy of the spreadsheet, right? And I'm going to move it to the end. right? And then you can label it, right? So you could say first normal form or whatever. But if you were to look at redundant information here, I see a lot of it, right? The first thing I notice is that project and project title um, have issues. Remember when I talked about the system thing? Oh, and I see other misspellings here. Project title. I don't know if these are not good. So I still am working on cleaning my data. So I might actually label this one and say something like clean data, right? So I still see problems. Like I might just get rid of all the system words. So I think we already talked about that, right? This seems to me like bad OCR output, basically. And it's one of the weird tasks of a data person is to kind of do what I'm doing right now, is just cleaning and adjusting data so it's better. Now, all right, can we look at this information and just say, this kind of needs to be a separate table, right? It does. Okay. And so what I might do is I might take all of that information and you know what? Wait, I got some blanks here. I got to figure this out first, right? So can I assume that what they intended here is for these 3 lines or 4 lines actually, or 4 columns to repeat here? And I think that is the case. So what I'm going to do is I'm going to do that. You notice I changed the numbers here? That was good. So let's switch that like that. And then I assume this one is going to repeat, oops, also. So these 4 pieces of information. And I'm not saying we're keeping it like this, but what I'm trying to do is fill out all the information. So when I break it to a different table, I can then eliminate the redundancies, but all the information in this table, at least to start with, is correct. Right. So if I was to break, let's just say these, okay, so this one says project and that one says project. All right, let's look at this and see, this is what you guys are wrestling with. That's the project manager. Is that information actually up there? No, it's not. So that's missing. So I might do something like I might, you know, MGR or something like that, project manager. Right. And notice how I titled it. And then we could also, oh, it was there. Okay. All right. So the height was hiding it. But we might put an underscore in between it, right? Because if we're putting it in a database, that's probably what we would do to it. Right? And that process would continue, but I'm going to actually bold that stuff to make it different. All right. So if I was working on a project, do all the project codes match up with the names consistently? And they do, right? So what that tells me is that at least these 2 columns can be in a table together. And well, it looks like these are all consistent too. And those are all consistent too, right? So this could all be one table. So I could just take this, right, and copy it, paste it to a different structure. Right. And I'm just like giving you guys examples here. And then maybe add like a project ID column that would be the primary key. Right. And so this is where I'm trying to lead you to here. Um, and then maybe I just do something like, well, that could be one that repeats a few times. So I really don't need these repeats, right? That can go away. Um, and I'm going to just show you here. I think I did a control Z, one too many here, but whatever. Um, anything that's redundant, I can now remove. Right? And it's easier Well, that's the same as the top one, right? Yeah, that's the same as the top one. So those will go away. Oops, Control Z that. Those will go away. Um, we already have the PCO 45. Those can go away. We already have HR. So really, there's only three types. You see that? And just by doing that work, we took all that information and really boiled it down a lot farther. And we would just give them these ID numbers. And then over here, what we would do is we would get rid of all this and replace it with that ID number that relates. So, for example, and just in order to make this efficient, I'm going to insert a column here and I'm just going to say project ID, which is a foreign key, right? And then we just match it up with the codes here. So it'd be 1, 1, 1, 2, 2, 2, 2, 3, 3. This goes back to 1. That one is 2, 2, 2, 2, threes. 3, 3, 3. And then all this stuff can go away. So I can actually get rid of those columns at that point, right? So I can kind of delete all those. Now, so this becomes one table basically, and then this becomes a different table. But all right, so we're moving in the right direction. But one thing that we're missing from the original table now is I don't know what to call this table, honestly. Um, but let's just say table ID. I don't know what this really refers to. And then each record here would become a unique entry. And we might just do sequential numbers like this. And by the way, if you work in Excel and you have sequential numbers, you can highlight them and just drag down. It'll do it automatically. And then we look for the next level of redundancy. Where are the other redundancy? We created this one table, right? And then connected it with that foreign key. So this connects to that. And we would give this a different name ultimately. Um, could we do the same thing with the employees and the departments? Yeah, we totally can do that. Now, I'm not going to do all of the process for you here, right? So this is one where I do want you to kind of work through it on your own rather than have me uh, fix it for you, right? And I will show you the solutions next time, so don't freak out to that. But I want to see what you come up with. And then we'll look at the solution and you can fix it and you still have a few days to get it in, by the way. I would surmise from looking at this information and what we've done so far that we can boil this table down to a much smaller data set. So in other words, I would make an employee table. I would make a department table, and then it's up to you to decide what the hourly rate is. I think the hourly rate is attached to the employee. So employee would probably have these three columns. Department would have these columns. As you break them out into their own tables, you'll add a primary key that will become a foreign key here that refers to that information. Right. So I'm basically telling you guys how to do it without doing it. So that's, I think we're looking at three tables here broken out and do those maneuvers I just talked about. Right. And then ideally, like when you create a table, and if you're doing it in Excel or you're doing it in some other mechanism to create it, you can snapshot this as a table. And this one I would probably call, like for example, I might call this project table, right? The employee stuff I'd call employee table. The department stuff I'd call department table. And then you could call this the master table or something like that. Okay. So that's my tip on that one. I know we're out of time, so I'm trying to be mindful of that. But I'm going to go back to the document quick and uh, do um, this process here is breaking it out down into third normal form, and you will get there. Now we didn't demonstrate these commands, but we're going to actually create a database around this, and we're going to do this next time, by the way, is to go through the process of actually creating the database. That's a big part of next week, so that will be demonstrated next week. And then we will build a database based upon what we created, and then we'll run one of those entity relationship diagrams to see if it turned out the way we thought it did. Did they all connect correctly? That's going to be our task. All right, folks, I'm going to leave you to it. I know this is maybe a little more challenging than some of the previous weeks because I'm not holding your hand all the way through it like before it's due. So there'll be a little more pressure to work on your own to try to kind of conceptualize it all. There's a value to doing that and like wrestling through it in your brain and what it all means. And then we'll show you the solution next week, and then build the database to go with it. And it'll lead beautifully into our next topic area. All right, so I'm going to stop the video here. This is kind of like the precursor for how to do the homework. So we'll call it part one of the homework, and part two will be the solution, which we'll do next week.